Yay, you're watching the video! Let's talk about the last section of Chapter 4, CPCTC. So it's a bunch of letters, but it stands for the corresponding parts of congruent triangles must be congruent. So what this is doing is it's tying in everything that we've learned so far in Chapter 4. So let's say that I have two triangles. And I know these two triangles here are congruent because these sides are the same, this angle is the same, and these sides are the same. Now the shortcut we have says that side, angle, side like this means that these two triangles are exactly the same size. Now this formula here, CPCTC, tells us that because I know these triangles are congruent, these angles also have to be the same. And these angles have to be the same. And also this side has to be the same. So that's it. Once we have proven that two triangles are congruent, we know that all 6 parts are also congruent. So basically all this does is this is going to add one more thing onto our proofs. So let's say we have these two triangles and they're in the coordinate plane. I need to eventually prove that these two angles are exactly the same, but we have no way to measure these two angles. So what we can do first is prove that those two triangles are congruent. So let's take a look. We have triangle ABC and triangle DEF. So what we can do is we can find all of their lengths and see which ones match up. So let's find the length of A to B, this length here. So remember, to find lengths of things we can use the distance formula or we can use the Pythagorean theorem. So figure out how many spaces you need to make a hypotenuse. So we turn this into a right triangle. We went over 1, 2, 3 spaces here and down 1, 2, 3, 4 spaces there. So those are the two numbers we're going to square and add together. So we get 9 plus 16, or 25. If you take the square root, that means that this distance here has to be 5. Now we're just going to replicate that and do it for all the other sides. So let's find AC. So this is a 1 by 3. So those are the two numbers we're going to square and add together. So you end up with 10, which we can round to about 3.1. And then finally, in this triangle, we'll do C to B. So connect, we got 1, 1, 2, 3, 4. So those are the two things we're going to square and add together. So this gives me the square root of 17. If you type that in your calculator, you get about 4.2. So this distance here is 4.2. Now this doesn't mean much because that's only in one triangle, but let's find the lengths of the other triangle. So let's do DE first. So to make this triangle, we go up 3 and over 4. Hopefully you're noticing a pattern here. So this side here is 5, which coincidentally is the same length as this side over here. And then let's find EF. So I go down 4 and over 1. So those are the numbers I'm going to square. So we end up with a square root of 17 again, which is the same thing as this side here. So chances are you're guessing what the last one is. DF is 1 and 3, or the square root of 10. So this is the same as this. So based on all of this information that we just found, I know that triangle ABC has to be exactly the same size. Now we got to go in order. So A to B to C was 1/E to 2/E's. So I got to start and go 1/E, 2/E. So it's triangle DEF. Now once these triangles are congruent, CPCTC says literally every single part of this triangle also has to be congruent. So the angles that match up are going to be congruent. So angle A and angle D are going to be the same. Angle B and angle E are going to be the same. And angle C and angle F are going to be the same. So we can prove that B and E are the same by CPCTC. Because those triangles are congruent by side, 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 we know that every single part of them also has to be congruent. So, let's do another problem. How long is JK? If you look at this, chances are you're going to spit out the answer instantly. But I want to know how we can justify it. So, how long do you think JK is? If you look at all these things, you have 2 30s, you have 2 19s, and only 1 41. So logic says that that also has to be 41 feet. But, of course, we need to prove it with geometry. So, let's make the statements and reasons column. This isn't necessary, but sometimes it's the easiest to organize our thoughts. So let's write down some of the information they tell us. So we know that both of these are 19. So we know that JL is congruent to LN because they're given to us. They're both 19 feet. And then another one we know is that these two are both 30. So ML and LK are congruent. Because again, it was given to us. And then another piece of information was given to us without us knowing it. Remember, we have a bow tie. So these two are the same by vertical angles. So this is angle JLK. And that has to be the same as angle NLM. So now that I have this, if you notice, this makes side, angle, side. I know that these two triangles are the same. So triangle JLK is exactly the same as triangle NLM because of side, angle, side. Now once I know that all of the parts that match up also have to be the same. So I can say that MN and JK have to be the same length because of CPCTC. That congruent parts of congruent triangles are congruent. So that's how I know that JK is 41 feet. So let's try an actual proof. So let's do some statements, some reasons. Let's write down our givens. So the first thing I'm going to write down is actually the second one because this is a little easier. EG is congruent to DF, given to me. Already has a little slashy marks on here. The other thing they tell us is that EG and DF are parallel. Remember, anytime they tell you things are parallel, you're going to end up using some sort of angle thing. So draw your lines out thicker, and then draw your transversal thicker too. That'll help. And then it's easy to see what angles they're talking about. This angle here and this angle here, because they touch both of them, have to be the same. So I know that angle EGD is congruent to angle FDG because of alternate interior angles. And then what's the other piece of information they don't tell us but we need to know? Hopefully you said this. So I know that DG is congruent to DG because of the reflexive property. So once I know that, I know these triangles are the same because I have a side, an angle, and a side. So triangle EGD is congruent to triangle FDG. So now we're trying to prove that ED is parallel to GF. So I want these two lines here to be the same. In order for that to happen, we got to know something about these angles here. But we already do. I know that angle EDG has to be the same as angle FGD because of congruent parts of congruent triangles are congruent. Now once I know that these angles here are the same, these two lines have to be parallel by one of our formulas that we haven't used in a very long time, but the converse of alternate interior angle theorem. Now when you do these on a test or a quiz, you'll have a word bank, so as long as you kind of know what you're doing, you should be good to go. If you have questions about this, make sure you star it or write it down or do something and I can answer them tomorrow. But what you need to work on now is the worksheet. That is due at the end of the hour, and the sub will collect it, whether it's done or not. If she does not collect it, you will not be getting any points. And then when you get done with that, you can work on IXL. There's 3 assignments. So, have fun, make sure you're doing what you're supposed to do, and I will see you tomorrow. Enjoy your day.